some updates on C++ module. I've been hearing about modules in C++ for, let's say, 15 years or something like that. This time it is real. It is coming. And what happened? So last summer at CPPCon 2015, I gave a presentation about a proposal that I was suggesting, and also an implementation that was coming. And you know, this is on YouTube. You can go and watch the entire video. It's about an hour, so I'm not going to repeat that. What I will do is just give you a brief summary of what is in there, so that I can, you know, move on to the things that happened after the CPCon presentation. So the idea for modules in C++, at least the way that I view it, as opposed to you know, what has been said on the internet, is that we need a system for C++ to first and foremost have what I call componentization. You must be able to, when you compose your programs, you must be able to express dependencies in a way that is understood directly in source code, right? And you must be able to isolate components properly. So for me, those are the most important. I know people saying, oh, they need better, you know, build throughput. Build throughput is very important, but if you do not have a good structure in your program, you won't go very far, right? It's just a mess. So the first thing is componentization. You isolate from the macros. So this is still a contentious point, isolation from macros. But it is essential, and I think people underestimate how macros actually are a drag on, you know, C++ programming tools. People don't appreciate enough, and it's kind of unfortunate. Then, of course, you want to have build throughput. It is extremely easy. If you have a structure in your program, it is extremely easy to boost the build throughput. Doing it differently is very hard, and people have been trying that for 20 or 30 years, as long as precompiled headers have been around, and C and that kind of stuff. And then the next thing that is not well emphasized, but that was, all these things were part of my design goals, was to have developer tools that are based, semantics-aware developer tools that are based on modules. When I look at my colleague and friends write C#, I'm kind of envious of how easy things are. Just pull stuff and then IntelliSense go boom, and then I'm there. I change little thing in my template header file, and I have to wait for 20 seconds before the IDE give me user responsive. That's just insane. And the other thing is, we have been talking about modules for far too long, and very little coming out. And I really want to deliver that. So last year, I was extremely, or 2 years ago, I was extremely optimistic that we'll get this in C++ 17. Then got the reality check with the C++ Standards Committee. It's like, no, it's not going to happen. You have to wait. It's like, okay, I'll take the TS train, but that wasn't my preferred route from the first place. And the other thing is, I don't really care about the preprocessor. I care only to the extent that it's preventing me from doing good stuff. Okay, I have no desire to improve the preprocessor. I have no desire to remove it. It is unrealistic to remove it in 17 or 18 because it has been run for far too long. A couple of months ago, looking at some bugs in a preprocessor and how to fix it. Oh no, can't fix it because people have been using a preprocessor to preprocess HTML file. Okay, HTML and C, they have nothing in common except characters. So the process has been long for far too long to be able to get rid of it, and improving it doesn't solve the problem. We need to look at something different. So these are basically the ideas behind the C++ modules. And a good news I can tell you is that this is moving forward. This is not just some blue sky research ideas. This is real and happening. So say this is happening. What are the, how can you use modules so far? I've been too busy writing, implementing modules and writing a spec, but thankfully other people have been helping me around, and so I did co-author the blog post that explained how modules worked in the Microsoft implementation. So modules are not Microsoft extensions, okay? You're supposed to be standard C++ feature, but Microsoft is the first to implement it in the way that I envision. Sorry. So I had a blog post, I think early January, that explained how modules work with the Microsoft compiler, and there's a lot of good stuff there. Please go and check it out. And then a few weeks later, I made another video that explained how modules, you have to write new codes, but you still have your header files. What if you want to consume existing header files as if they were modules? And so the second link explain how you can make that work again with the Visual C++ compiler. Kenny Kerr, who has joined Microsoft recently, he has been working on this tool for what he calls modern C++, just a way to express WinRT projections using standard C++, not C++CX. And so he has been doing it in terms of generating header files on the fly, that kind of stuff. And he has found modules quite very useful. And he wrote several educational materials on it. So the first was this blog post, Getting Started with Modules, which came at the same time, I think, as Update 2. And then a recent article in the MSDN also talk a lot about how you consume and produce modules using the Visual C++ compiler. That is good stuff, and I encourage you to look at it. And of course, I'm also preparing, a book. You have to teach people how is this thing used. It's very important that we're able to teach people how to effectively use modules, not just talk about it. But writing code, writing a spec, and writing books. I'm learning how to make that happen. In the previous life, as a professor, it was easier. Just tell student, write a code, and I'm going to write a spec for you. So these slides are taken from the CPPCon talk. So if you really want to learn more, please go and the slides are also on the web. Everything is available. So this is where we are today. So Bjarne likes to use this abstract data type called dates. If you try to implement dates in C++, you'll learn a lot about data abstraction and code organization in C++. So, on the right-hand side is just essentially the production of a date class, very simplified. And on the left side is a consumer side, right? Production side is done once, but you have a lot of people consuming it. And so this is where we are today, and what I actually hope we will be, what I'm suggesting we move to is this place. So you don't see a lot of changes, right? The changes are essentially what's in yellow. So the includes and define, that kind of stuff have been replaced by some import statements, and some keywords appeared, like export. So essentially on the right-hand side, we'll say is, well, I'm taking dependency on stud.io, string, and calendar month, and I'm going to produce something that belongs to the module calendar dates. And you can use namespaces. Modules in C++, the way we're having it, are independent, are orthogonal to namespaces. That's a deliberate design choice. And so if you want to make something available to consumer, you just write declaration the way you write it, you stick an export keyword in front of it, you're done. So that's basically the way it works, right? So you just need to stick and import keywords, and a line that says, anything from here on is part of the module, that's it. everything before the module declaration is in a global module is not exported. It's not, it's really in implementation detail. This is where I want us to be, right? So the changes in terms of consumption side is very minimal. And also on the production side is really minimal too, if you look at it in the bigger scheme of things. So if those are the only differences, why is this a big deal? Yeah, so back in the summer, I actually ran this through a couple of compilers. If you take the original what we write today with header files and the implementation I had, and you run it through a compiler. So this very simple program is 176 bytes. Fantastic. That's what I see. That's what I show people. It is small. It fits on a slide. It fits on a book page, and I can talk about it. Now, that is not what the compiler sees. What the compiler sees, so I run these 3 compilers. So again, this is not the latest version. This is the version I had in over the summer. Sorry, I didn't have time to run again. But essentially, GCC will give me about half megabytes, and Clang say, well, I'll give you a byte and more, and VC is just behind Clang, right? That's insane as a compression rate, right? That's what a compiler sees. So it's just insane. The reason is we use includes, directives. Include directives are copy and paste. This is a point where we have C++ where we have this notion, you don't pay for what you don't use. Except that when you run these 3 things through the compiler, you'll pay for things you don't use. Like, IOStream will bring in a lot of stuff that you actually don't use. Because it's copy and paste. The compiler has to pass everything before it gets to your program. Right? That's why things are slow. That's why it's bloat. You pay for things you don't use. So what I'm suggesting is we go into the module world and we ensure that when you import something, you pay only for things you use. Or I would say differently, you don't pay for what you don't use. Right? Meaning that sometimes it could actually be free. Okay. So this is the state where we are, and I want to improve this, and modules are improving that. The other problems that I'm trying to solve with modules is a little bit improve over the program organization in C++ today. Right? Earlier I said componentization. The way things work is you have your include files, and the processor goes and copy and paste everything in a header file. And then you have this gigantic thing we call the translation unit. Basically what it is set of declarations, external declaration, internal declarations, and stuff. But when you have 2 or 3 such translation units that are going to be part of the same program, none of them knows that they are part of the same program. They just compiled in isolation. So there is no real way to convey information from one translation unit to other, right? And that's why things are so brittle. That's also why types of linkage in C++ is still work in progress. Those are things we can solve, and they're real problems. In practice, we see a lot of bugs, security vulnerabilities that are related to ODI violations, that kind of stuff. We can solve those problems. Okay. And the other thing is, it's quite amazing. Because we have these isolation of translation units that it's separately compiled, the compiler would work very hard to produce a bunch of instantiations. And then the linker is asked, well, just throw all of them except one. Okay, that is not green computing in any sense. We're just using, wasting resources. However, there is something quite interesting, and then this is ingrained in how we build programs in C and C++, and we cannot lose that when we move to modules. Otherwise, we get riots. Okay, so here we have the main program. in the second column. What it says is, hey, I know about some function called quant. It takes two ints and returns an int. So it is that translation as saying, hey, I know that thing, please call it. But should that be the case? Shouldn't be the producer will tell you exactly what the types are, how things are to be consumed. That's not what we have today. So you can actually build two programs out of these three things, right? You can, if you have this translation unit, that just produces this definition of quant. You link them, you get one program. You can get another program by providing a different definition of quant, okay? And it is used in system building. So imagine that you're trying to bring up a system and you just need stub definition for some functions that you really don't use, but they mention somehow, you don't use at runtime, right? Because you have some flag that say, oh, this is bootstrapping, so don't call it, and I can't. But the linker static doesn't see that, so it need to bring in some definition. So this is something we use today to build systems, and this capability, we have to retain it somehow. It doesn't have to be anarchic like it is today, but we have to retain that capability. And modules retain that way of doing things, right? Okay, so the other thing is, like I said earlier, the linker, so the compiler would generate a lot of symbols, right, and definitions, and then the linker, especially if you use template, then the linker is asked to go and throw away almost all of them. And the reason we have that is we have this notion of one definition rule, which is very dear to C++ programmers. C programmers tend to not know about it or think this is some kind of esoteric philosophical point that has no place in software design. But the truth of the matter is that Dennis Ritchie, when he invented C, he actually had one definition rule in mind. It was Bianet who formulated it in the way we know today, but Dennis Ritchie had that in mind as part of the C spirit. And I was like, yeah, well, yeah. I asked Dennis Ritchie, and he said, well, it's as if there is only one section of code, source code in your program. So the fact that they had preprocessor was just a quick hack to get systems up. And then, every time you get some quick hack, it gets a life of its own and has followers, and you have a new religion with it. So that's how we got a preprocessor. But in C++, Bianet worked very hard to make sure that we don't lose sight of the one definition, that it becomes part of everything we do with C++. The end result is, if you take, there is one section in the standards called one definition rule, and if you can read it and explain to me, you deserve to be in car. You deserve to run car, okay? Because I've been in that group several times. I've seen that you still have some, bug reports in the standard related to one definition rule. It's obscure and opaque in a way that you wouldn't believe for something that fundamental. And the problem is, everything we put there is because we don't actually have the true one definition rule in the center. We put things there to work around. Every time you work around something, it comes back and bites you, and very hard. And Bianet's way of saying is, every single word about token comparison. So if you look at that section, it talks about name lookup, token comparison, that kind of stuff. It says every single word about token comparison is there to work around absence of a real module system. And it is a problem. And hopefully we'll be solving that in a way that's more understandable and more mechanically verifiable, and brings type-safe linkage, true type-safe linkage to C++. So what really is a module? So imagine that you have this box that has an interface. You can look through onto the interface space. Those are the entry points into your modules. Everything else behind is an implementation, is hidden behind the module interface. So a module is going to be a collection of translation units, just like we have translation unit today. The reason is this module system is an engineering work to bring sanity to C++. This is not an exercise in new language design feature the way you'll find it at conferences like POP, PLGR, so forth. There is an existing system, bring sanity to it. Okay, so we have to start with the translation unit. Those are the things we have. Now, how do we deal with it? So you have translation units, and then you have a set of declarations that we call exported declarations. Those are the entry points into your module. Everything else that is not exported is not reachable through naming from the module. Okay, so that's the first thing. That's how you bring boundaries, and you make components more visible in your software architecture. And then a module has a name because you must be able to take symbolic dependency. Every single element in module, we call it a module unit, because you have a translation unit and a tag or something that says this translation unit is part of that module. So there is some kind of identity to it. And a module will own every declarations in there, in the sense that you have a module that has function quant that takes 2 int, returns an int. And then you have your own, and we don't export. We should be able to link in the same program and not have ODR violation. Today you can't because you have ODR violation. If both functions are exported, then you should have conflict because I don't know which one you meant. Okay, so that's the idea. From the programmer's perspective, what really is a module? Oh, it's just something that allows you to not be at the mercy of macros, right? I spent 15 years working on GCC, and one of the things I learned was macros, even if you're extremely cautious as an implementer, they still come in ways you wouldn't expect and bite you. So the first thing is isolate people from macros, right? When you have a module interface, when you import a module, what gets in there is the compile interface. So something that has been already processed independently of your context. So if you have a macro definition in your context, it doesn't affect the module interface. Okay, and if there was a macro in that module interface that was compiled, it doesn't affect yours. So everybody gets their own stuff and things are properly isolated. So this is a fundamental design point. I know we still have debate about whether you should be able to bring in macros from the outside, but my view is once you start making that possible, you have given away everything and you can't make any progress moving forward. So in the current specification, a module interface is supposed to be defined at a unique place. You are supposed to have only one source file that contains all export declarations. I'll tell you right away, that is a draconian restriction, and I recognize that. But I put it there so that we could start talking about modules, using them, and then solve that problem later. The problem is this. In C++, before you can parse, even tokenize, right? It's not parsing, it's tokenizing correctly. You need to know whether a name is a template, right? So if you spread your export over several files, how can I start processing one of them? I can't, because I have to know whether anything that's used from the other side is it type, template, or so. The idea is just put everything in one place, and we'll use traditional compilation units. I don't think it is fundamental. I think we can relax it, and I'll talk about that later. But it was essential for us to focus on the essential part, and then solve that engineering restrictions later. Okay. The other thing is that we actually, with modules, we actually have the one definition rule, right? Every entity will be defined exactly once at one place, because it is an import, something that is language, it has language semantics opposed to preprocessor where you just copy files. You don't have to resolve, oh, I have 25 definitions of class foo. Which one should I pick? Oh, and the son will say, well, start comparing tokens and then do name lookup and to decide whether they match, right? Now, you have only one place. When you say import, if you don't use the class, it is not even there. If you use it, it will materialize. But if you use it 25 times, it's materialized only once. And if you import that class in several translation units, they will be coming from just one single place. There is only one definition. Okay, so we actually get through ODR, and you can see that through the build throughput. And I was having a discussion earlier in the day. A colleague of mine was using modules to build some new stuff in Microsoft system, and he went from using header files 20 seconds to less than a second using modules. And my manager was, oh, holy crap! And I say, yeah, I like the sound of that. And that is where I want us to be, right? Where it is instantaneous, and on top of that, you could have semantics-aware developer tools. You just import these things, then it just, discoverability is easy, right? So the other thing is, I really, really, really don't want us to have a new name lookup rule just because we have modules. Who here knows how many rules, name lookup rules we have? I don't. I tried to count it 2 years ago, and I thought I had something like 7.5, and that doesn't sound like 7.5 is the number that you would ascribe to number of name lookup rules. So I'm sure I got it wrong, and I asked the core working group. They couldn't give me the right answer. So here we are. I haven't seen any case where someone tried to improve over name lookup rules and didn't get surprises. So fundamental thing, we are not going to get new name lookup rules. Okay, so how does it work? Well, we can engineer behind the scene to ensure that as a user, you don't get name lookup rules, new name lookup rules. You don't need to know about any new name lookup rules. We can restructure the existing name lookup rules in a way that it is in stage. You don't have to learn about them. They are doing, from end to end, they are doing exactly the same thing. Okay, so that's what is in the specification. And the other thing is that modules, you have to know, they do not replace header files. There are certain use of preprocessor to generate text. Purposefully generate text in a way that, oh, I just include some data generation or some macro expansion that just generate text. Modules will not do that, right? Because if you include a module twice, just as if you include once. Whereas in these cases, when you include a header file twice to generate text, usually you expect the new inclusion to generate more text, right? We have these things. And of course, once we have these structures in place, we will get build time faster. And now we have proof that we can get it much faster, by at least 15 times. That this is not percentage, right? This is factor. This is what we want, and this is what we want to aim for. Not that it is 25% faster. No, that's not an achievement. Okay. Now, so from the implementation side, I have this idea that, so when you compile a module interface, it will generate some kind of metadata, so what I call it IFC, just for interface. And then you have your traditional OBJ. You can put them together, and that's the only thing, self-describing modules or a package, or not package, but binary that you can ship to your customers. This is not required, but it is something that is possible, right? So you have something self-consistent, self-describing. So now imagine that you're loading share libraries. Now the symbols that you're loading is well described with the metadata that you need to make it done, right? And we can also design the interface file, binary file, in a way that is relatively compact. So the example I talked about earlier, my friend, a colleague, had something like, with PCHs, had something like 1.5 gig of PCH. And when compiled with modules, it was 175 meg. Okay, and this format that we had is just very simple, and I'm pretty sure we can have much better than that. And I'll be working on that in the next months. But once we get that, you see that now there are things that are possible that we couldn't do before, right? The fact that you have a binary description of the module interface means that you can actually load it at runtime and query it and do things in a very type-safe way. Things that people will do in Python or C# or Java, now you can do it in C++. Furthermore, if we make this IFC has a standard format, technical specification or something that is shared by the community without being part of this standard, now you share more knowledge. You're supporting development of the tool ecosystem about C++. That's what I want us to do. Okay, so at the Jacksonville standards meeting back in March, we had a vote to open a new work item for C++ modules, and meaning that this is really happening. It is not just papers that we talk about. This is really happening, and the process is underway. And I expect it to be closed by mid-June when we get to ULU, which is next standards meeting. The ballot process will be done, and we'll get the result. So far, what I know is that the U.S. delegation is in favor of it. I heard from the French that they also big fan of the idea. They're in favor of it, and then I hope other nations are also in favor of it, which means that we are making progress compared to, let's say, 10 years ago or 15 years ago. And I'm really happy about it. At the last meeting, so the Google folks, they have been working on some notion of modules for a while, since 2011 or 10 or 11, what they have called module maps, which is essentially some kind of configuration file that you write on the side that instructs the compiler to treat existing header files as if they're modules, or import these header files. That depends on some. It's not exactly modules. It's just something on the side that gives the illusion that something is modularized. Of course, every time you try to give illusion or to fake something, you get some other problems. But based on those usage, they have some ideas about how to amend the module proposal that I put forward, and that was discussed extensively at the Jacksonville meeting. I'm looking forward to a revision of those papers, to help us have a better system for C++. One thing that I would love to solve, and I mentioned earlier, is today you say that you have to put your exports in one file, in one place. And one of the feedback I got from users using this in product group with Microsoft is they really love to be able to spread those exports on several files, and so we need to find ways to make that happen. I have some ideas, but I would love to also see work with the Clang folks to make this progress. What else? So, well, from the implementation side, the current Visual C++ release, which is Visual C++ 15 Update 2, has a better implementation than the first preview. The Update 3 is coming soon, and we've fixed even more bugs, so the next iteration will be much better. I've heard that some other implementers they want to invest in implementation in Clang and GCC very soon. That's very good news, right? This is a place where we, for something this fundamental, we want an implementation available in all C++ compilers, not just Microsoft compiler, right? This is so good that you can't wait till the standard is done before implementation starts. So I hope to hear more from those efforts. And I don't have a formal preference numbers to share publicly, but I mentioned the experience earlier. I'm extremely very hopeful that we will get not percentage like 15% or 20%, but real factor like order of magnitude. That's what I'm aiming for, and I would love to work with other implementers so that we get to a place where this improvement is not unique to one compiler, but is shared across all compilers, and an experience that every C++ should expect from their compiler. Right. The other thing is, as we're working on the metadata, it became clear to me that we need to have a common format, the binary format for the metadata, and thankfully, this is something that I worked on with Biane more than a decade ago when I was in Texas. Then I designed a semantics graph, semantics representation of C++. At the time, this was done between 2004 and 2005 or 6. So it was way before we got all the new C++ 11 features. But since we're working on the committee, we also knew those things are coming. And what we did was to ensure that we have an idealized C++. So this semantics graph captures a language, and that language is a superset of C++, where anything that makes sense to think about in C++, you should be able to express in there. So the interesting thing is that it's a library. It's extremely small. It's available. You go to on GitHub, you can get it. The implementation is extremely small. When we did this, it was 2004, 2005. Doug Gregor was also implementing GCC concepts and has issues with performance. And then we shared the result that we got from the IP era with him. And the next thing is that he actually convinced the GCC folks, and he implemented this, to actually take these ideas into GCC, so that now you have what we call unified type tree. So before this work in GCC, if you mention type foo, it will create several foo type nodes. And so every time that you need to check whether these two types are the same, it will go and do structural comparison. And with this work, what we actually have is, if you mention foo 25 times, there is only one node that is created internally in the compiler, and that it reduces memory usage and improves compile time. And he used that for GCC concept GCC implementation, and saw significant win, and that made it into GCC. So this is work we did more than a decade ago, had already impact on existing compilers. So what I'm suggesting here is that we use that as a foundation to describe the binary format for metadata for module interfaces. And so in the next months, you'll see stuff coming from my team, and that's based on this, and I'll try to describe it in a way that is fairly general, compiler neutral. That thing is compiler neutral. I can tell you, so it's 2003, 2005, I was still working on GCC. I had an integration to the GCC, a compiler which is in fork. Andrew Sutton, who is working on a concept, when he joined us in 2011, he had an integration to the Clang compiler. In 2007, we had a student. He's now developers at Microsoft, Yuri Solotsky, who actually integrated to the time it's called the Phoenix compiler. And we had another integration to the EDG compiler by another student, Peter Picklebauer. He's now a professor in Alabama. And we know by integrating to 4 different compilers that it is possible to have this description and this data structure that is compiler neutral. It may not be, if you take a given compiler, it may not be the best, most efficient implementation for that compiler, but if you take all the compilers together and you want to be neutral and faithfully represent C++, this is close to unbeatable. Okay, yes?
Is it big endian or little endian, or how does it resolve that problem? Because I got the gut feel your compilers are probably all little endian.
Well, actually, not all compilers are little endians, but yeah. So the one I know about, like GCC and VC or Clang, so they have their own representations that is very symbolic, right? The endianness is something that you resolve at the code generation level, but at the semantic description level, you do not need it. And just the same way we did it for const expert. So for that const,
my point is the binary file format itself.
Oh yeah, the binary format the binary format itself, yes, will have a flag that says whether it is generated for big endian or little endian. But the semantics graph itself is independent of endianness, just like we have for const expert and that kind of stuff. Yeah, thanks. So the code is available in, this is something that we did when we were in Texas. The license is very permissive, BSD, 3 points BSD, and hopefully soon you'll see more stuff coming out of that, based on that, and integrated to compilers like GCC or Visual C++. Did you have a question? Oh, no. Okay. Okay, so I think this will conclude all I wanted to say about modules. And so sorry I don't get too much into details on this one, but you'll hear from me about this in a few months. Okay, so I'm ready to take questions. Yes? So like I said, this is the work we did when we were a professor at Texas A&M. And one thing that is there when you're employed by a state university is you actually don't get to impose your license, you get to choose from license. So this is the one, from the list of choices we had, this is the one that looked to us as the most permissive. Everybody who has worked at university knows this, right? A lot of the folks went through this. They changed recently their license because the previous license was the one they got from University of Illinois, right? When you work on projects that is sponsored by the state or federal government, there are certain constraints that you can only choose from. You can't impose. Yes.
2 questions. Can they kind of correlate? What do you do about circular module references? And the second one is, how do you resolve a problem that someone may wish to update one module and not the rest of the system?
Okay, so the way, now to rephrase the question, two questions there. The first is circular dependencies between modules, and the other one is versioning of modules. Okay, so circular dependencies, and at the interface level, dependencies of module interfaces has to be a directed acyclic graph. So there is no circular dependencies. However, in implementation units, you can have, if you call it circular dependency, that's okay. And the acyclicity at the interface level is just a requirement that's enforced at compile time, right? Now, versioning of modules. The proposal at this point does not have any, does not talk about versioning, in the spec. It is a problem that is very difficult. Mostly related to compiled module, not the module, not the source code, right? It's the compilation level. So at that point, then we use, traditional implementation defined way of dealing with versioning. You store versioning in the binary format to timestamp to check the dependencies, right? So at the spec level, there is nothing there, but at the implementation level, yes, we do store timestamps too.
So theoretically, it's possible for someone to break a module interface because they needed to version in a new one, and they're not recompiling the whole system between compile and link.
If you set up properly, yeah, you can break. If you can set it properly, you can break the system, but you have to go very, very far. Yeah.
I'm saying one or two.
So I don't know who got. So go ahead.
How does this work when you want to export a template? Who instantiates a template and where does it go? So, right. So, like, I want to export basic strings.
Mm-hmm.
How is that going to work in the context of a template?
Okay, good question. So the question is, what about template that are exported? So that's actually a very interesting place, and thanks for the question. So when you look at a template that is exported, the first thing is instantiation. So if you use a template on specialization on template argument, if the template argument list, a bunch of things in there, happens to depend on something that is not exported, then the whole instantiation is local to that translation. It's, even more than that, it's local to that module, right? Now, if you have exported template, an argument list, and everything else is exported, then this is something that is visible to the entire program, right? So, the definition is you follow the one definition rule. But concretely, the compiler is going to generate the instantiation and key it so that you can share it across modules, not just translation, it's modules. So that's what we're trying to do. The other thing is when you have a exported template, you can also say, I'm going to export some explicit instantiations. Like most programs will have vector of int or vector of size t, right? And it makes no sense for everybody to go and instantiate their own vector of int or vector of size t. So you can, in the library, for example, say, well, I'm going to export vector of size t. What that means is that when a compiler says, okay, I'm just going to generate this instantiation once, and I will never going to generate it again because I know what it is there. So that is there. And you know that in C++11, we had this notion of external template. So when you export an instantiation, it acts as if you had an external template instantiation. So did I cover what you're expecting? Yeah, thanks. Got a question.
So it's a follow-up to circular dependencies. I think you can have circular dependencies in an interface if you have, say, two classes and two modules, and they have methods that take as a parameter an instance of the other class.
Yeah, so it is conceivable to allow circular dependency at the interface level. Then you need a two-pass parsing to resolve it. My view is that it is rare that you'll be in organization A, have an entity that depends on something that I produce. I'm in organization B. Then me producing that service to you will have to depend on you, right? So when you have that circular dependency, my view is that you actually have one module. It is just some kind of convenience to try to break it into several modules, but logically from architecture perspective, they belong to one single module.
So if a module is shipped as some kind of library with included metadata,
Yes.
that describes it, as a programmer that wants to consume that module, how do I explore it in a way that, like the IntelliSense gives me, to say, what are the definitions, the types, how do I make use of the methods that are exported by this module?
Excellent question. So the question is, well, if I give you a binary file format, how do you explore it? Whereas if I give you a source file, you can just go and read it, and you're good. So when I'm talking about tool, semantics-aware tooling, that is precisely that. I want the ability for folks to actually explore, discover what's in modules, right? And clearly, the IntelliSense will know about this. As a programmer, you have tools that allows you to actually, I would say dump, but lists methods, classes. Sorry, I shouldn't be saying methods when I'm talking about C++. So functions. Functions, classes, namespaces, comments, right? So one thing I've been grappling with is that originally when I was designing the IFC format, it was like, this is something that should be only semantically relevant. If you, in your module interface, you change something that is not semantically relevant, you shouldn't, consumers, people who depend on your module, should not have to be recompiled. If you change a comment, it doesn't affect over resolution anything else, right? If you change a private member in a way that outside folks shouldn't care about it, you shouldn't have to recompile. But then the question comes in, how do I deal with comment? People, if you give me only the binary, how do I deal with comment? So this is a place where we are still looking at the engineering trade-off. And to reassure you, not just because you're going to ship the binary interface means that you wouldn't have to ship the source file out of it. It was compiled, right? So it is not a replacement. It is just that you're going to have a library that is self-descriptive in terms of binary. Okay. You'll have the tooling to explore it, and you also have the source file if you want to have. I'm seeing head shaking, so I want to.
Because if I'm company A and I want to produce a module for the people to purchase, I'm not going to give them the source.
So
they'll get the module interface, they'll get the link files, etc.
Yeah, so there is nothing there that will force someone to distribute IFC, if that's the point. I fully agree with that. But what I'm saying is that, in the end, I suspect that in many cases it will be in the interest of people delivering modules to also deliver the source of the interface. Even today, you can deliver .libs. You're not required to deliver a header file. You can just tell people, oh, just write extern function for something and you're good, which is practice, right? So the larger point remains that you have the metadata and you have also tooling, programmatically, right? Not just one single tool like obj dump or something like, but really you have APIs that you can program against. That's my view, that it shouldn't just be a tool like obj dump or link dump, but something that you can program against. Imagine you want to type safely load DLLs. Today, if you want to load an entry point, you have to make it, most of the time you have to make it extern C, because that's what allows you to escape the name mangling stupidity, right? But if you have this description, it becomes easy, because now your library can just say, give me the function full with type int returning string, and it will take care of mangling whatever it has to mangle, behind the scene. Now you can have entry point that are C++, not just that extend C business. Yes.
So you said earlier that modules are logical to be processed. So what happens if I cannot include a header file that I'm functioning or a module that has a name conflict with that function? Where's that? How's that going to be resolved?
Okay, so I'm trying to. So let's say here you have some imports. Hash includes something, and then here you have a function definition, and they have the same name.
Yeah.
Okay, so if if they're overloadable, then you're fine. But if it is same name, same argument type, then you get conflicts, right? And you don't get to resolve it. There is no module name qualification to it. It's a deliberate decision to keep it that simple. Walter?
Oh, I think you answered my question. There is no module symbol table. It's sort of distributed in the global symbol table.
Let's get into some implementation strategy, right?
Well, if you're going to find name collisions, then it has to do symbol lookups for each symbol in the module.
Well, the thing is, you do ordinary name lookup, right? Ordinary name lookup would consider things from where it is up there, right? So if you're in a module, you have the one in a module. So because the modules are independent from namespaces, you have the global namespace from there, and the one from the global module, it gets conflict. Remember, each module owns declarations it exports or it defines. So behind the scene, the modules where an entity was declared or defined is part of that entity's identity. Now, whether that identity is made available programmatically to the programmer to resolve name, ambiguity, or is something that I don't want, because once you get there, I don't know whether you multiply, but at least you add to the name lookup problem, and that is scary. Should be scary. I mean, how does ADL work in that world if you can start, resolving with module names and qualified so forth? Yes.
So what you're saying is that the module concept is totally independent of the namespace.
That's right.
So that if a module wants to make sure that it doesn't collide, then the responsibility of the writer of the module to make sure that its names are in a particular namespace.
That's right.
Won't collide with something else.
Yeah. So the collision will be detected at compile time or link time, right? But it will never be silent, right? You cannot silently mistake one symbol from another.
Another question. Much of the advantage to header-only productions, libraries, is that they tend to go away in compiled code. And the things that are in the headers end up inline into the code that you end up executing. Where does this module concept interact, or does it, with the concept of inline implementations of the functions?
They coexist in the sense that so this example I gave earlier of something producing 1.5 gig of PCH is actually header-only library. So the way it works is this: most of these header-only libraries tend to be template or inline functions, right? So today we have no mechanism of saying, oh, I have this template, but it is only implementation detail. Well, we have conventions like boost : detail. Say, oh, this is for, it's not supposed to be user. You're supposed to mess with it. It's just for implementation detail. Now, with modules, you will be able to say, I'm not going to export the detail namespace because it is only implementation detail, and there are only these templates that I export. Right? When you put that in a module, you can just have one single module that contains your header-only implementation, and you compile it. The compiler will store on disk all the necessary informations to be able to instantiate later, right? So essentially, exaggerating, you'll say, it will save some copy in some form of it, right? And when someone imports your module, they will get only things they use. And if that thing is inline, it will be inline. When that thing is instantiated, template is instantiated, it will be instantiated in the context of the use. So if the use is only with arguments that are exported, then you get this global entity. If at least one of the entity used to instantiate the template is local, it will be local to that translation unit or module. So you retain all the goodness that you have to do with header files, only implementation, plus componentization and isolation.
So the idea is that the compiler is smart enough to take these module interface definitions and turn them into inline code when that's appropriate.
That's right. It saves enough information to instantiate a template. So that's why there is a requirement that if you export a template, that exported declaration has to be the interface source file.
Okay.
And the same goes for inline functions and const expert functions.
So in effect, you're saying, given your example, that because the definition of day, month, and year is part of the export, it's possible to inline them.
That's right. Yeah.
But the definition of the instantiator date isn't in the export, therefore it has to be implemented by calling the module.
Yeah, to some degree. The other thing I wanted to stress is that not just we got module means that we're going to have some kind of indirections of vtables. No. This remains C++. And one of the things that I put in the design paper was that adoption of modules should never be cause of the root cause of slowdown, performance runtime performance slowdown. It remains C++.
You're exporting the subscribe date, or you're exporting chrono.
Yeah, so if you're tired of putting export here, you can just put export here and not bother with
So if you can do that on a namespace, what like the namespace chrono? What if I have a second file called green.day.cx? It's the same module, but that find namespace chrono without export. What would this one mean? All the namespaces that are right, the one that don't have export,
Okay, so thanks. The first thing is that in C++ today, namespaces span across translation units. So if you create a file list, it has namespace. It's the same namespace std as vector or map or whatever. So that means that in the module design, we had no other choice than to make it clear that namespaces are always exported, no matter what, except the anonymous namespaces, right? Or namespaces inside anonymous namespaces. Those are local. So when you put export on namespace here, what is exported is not a namespace because it's already exported. It is the declarations that are in that open curly, close curly. It's all the declarations that are exported. So it is a shortcut to putting those exports. Now, if you're in a different file, you didn't put export on the namespace, but only on declaration. It's only that declaration that gets exported, right?
But it's a declaration inside a namespace if it was namespace.
Yeah, so if you reopen your namespace, but you don't put export on that namespace, it doesn't export anything. You have to. So putting export on namespace is just for the set of declarations that are in that lexically in that region, right? That's the way it's supposed to work. I think that in
One of the biggest remaining annoyances after converting a 20,000 line Windows utility was all the silly little Windows REST ANSI defines the Windows functions. And because I don't really like the preprocessor defines much myself, but need a way to have some sort of once we have modules, we think you'll have enough ammunition to actually accomplish something like scale this keyword using syntax like using create window w equals create window, or create window equals create window. Because otherwise I have to look for all the functions.
So the question is, when you look at Windows.h today, we have a function like create file. But the name create file actually is a macro, right? Because the real functions are create file W and create file A, W wide and C. And then you have this macro stuff to make the impression that you have actual function called create file. And then behind the scene, people create aliases to make things match. Now, the question, if I understand correctly, is now that if we have modules, will there be any mechanism to allow some form of aliasing to get rid of these macro chicanery? Is that?
And it actually respects scope as well.
Something that also respects scopes and okay, so macros and scopes, they don't go together. So this is quite an interesting problem, and I've been collaborating with people in the Windows division, and some of the papers actually I wrote, like the transition path into modules. It was a paper for the standards committee back in October 2015. Was the co-author Pavel Curtis is actually the architect leading the conversion to modules in the Windows division, right? And we've talked a lot about this Windows .h problem, and they have several options, and of course aliasing will be one of them, but from what I understand, it's not clear that's where you want to go. So the aliasing problem is not critical at this point, but clearly since they're converting Windows, they're also the people who don't want macros. So this paper was about you shouldn't be exporting macros, and Pavel Curtis, really feels strongly about it, and he's in charge of Windows.h. So I suspect that he understands the problems at hand, how wide it is, and they have. I'm pretty sure they have good solutions in place to get there. You and.
So by doing this, is the IFC format going to be standardized? And if you're doing that, are you de facto standardizing the ABI, even if you're not explicitly saying it's on standard?
So the question is, if we will the IFC be standardized? And if we do so, wouldn't that standardize an ABI without saying so? So first question, will this be standardized? My hope is that at least it will be shared by the C++ community. When I get time and during progress, I'll write a document to WG21 for technical specification or something like that, and see where it goes. But at least I want the C++ community to have a shared format. So to the second question, whether this would standardize an ABI, I think the answer is no, because the IFC format, what it does is to describe C++ entities at their most abstract level. So it is faithful to whatever comes in source level plus semantics resolution, but it doesn't imbue that with a specific ABI that the other guys had to solve. So if you're GCC Clang, you're targeting Windows, you have to obey Windows ABI, but that is not because you have modules. Similarly, if you're targeting Linux, and you're Clang and GCC, you have to obey the Linux ABI, and not because it is of modules. So it will not standardize. I guess the point you want to make is make sure that you don't do this by accident, right? And it won't do it by accident. Yes?
So what if the import is compiled with different compiler switches than the importer, such as one's compiling for 32 bits, one's for 16 bits, for 64 bits, which will of course change the semantic meaning of the code. So how is that dealt with? Is the import only stored as syntax?
So we have the general notion of configuration parameters, right? It's like, am I compiling for x86? Is the symbol underscore Unix defined? There's a bunch of parameters that comes into play when you invoke the compiler. All those informations are stored in the IFC. So if you're going to target x86 and x64, you're going to compile the same module source file twice, right? Once with x86 and one with x64. This is not an effort to have an architecture neutral description. It is a compiler neutral description, not architecture neutral description. So you still have the configuration parameters in there to check for coherency.
This is much more general than just 64-bit versus 32-bit.
Yeah.
There is
The debug.
level of optimization.
Yes. Trading model.
Stuff.
Yeah.
There's all kinds
Yeah. So I gave those two only as example, but they're obviously not the only one. You're absolutely right. So trading model, a bunch of other stuff that I didn't get into, but that we know are there. When you invoke CL, it has a lot of things behind, like define a bunch of macros that are essential in ensuring coherence. And yeah.
So if I have a library from somebody compiled with full optimization but no debugging symbols, and I want to link it with, somehow use it in my code that has has all of the debugging stuff on and no optimization. Are those incompatible, or do I do something to?
Yeah. So today it is the case that if you ship only a binary, it's like in debug, using HCL with debug, for example. Most HCL implementation will have completely different representations. That's vector or string based on whether you have debugging on not debugging on, and if you want to mix them, you get ODR violation, which would be a silent crash, right? With modules, what happens is that because we store the configuration parameters, we will be able to tell you in advance, hey, you can't mix these two. And this brings me back to a comment I was making earlier, that even though you'll be able to ship your binary with the IFC, you should have incentive to also ship the source out of which the interface was compiled. Because if you only offer a limited choice of compiled binary, compile module interfaces, and people want to use your library in other situations, they'll be blocked, right?
That applies to what's your hardware. What's your length of your AFX vectors on your particular thing that you're doing?
That's
you have separate versions of it. For different vector lengths.
Yeah. So if we, I gave the example of Windows.h earlier. So if you take Windows.h, for example, if you look at it, it has a lot of macros, more than thousands of macros, and you can imagine that we really don't ship more than 1,000 different configurations of binaries. So, yeah. But I guess the point I'm trying to make is that while you could have, potentially infinite number of parameters, in practice, it turns out that when people ship libraries, it's the set of configuration parameters that makes sense. That essential is fairly small. Okay, okay.
Quick question. So Java, with its instructions and reflections, allows you to kind of monkey wrench things that look like they're encapsulated, but they're not. Have you thought about any kind of debugging help that you're going to give people who are going to write modules? Or is the theory that you write all the unit tests that are, white box, so you can see everything down inside the module and everything that's totally black box that's outside? Or is it actually monkey wrench
Yeah, so that's excellent question. So that is the phase where I want to move to now. In presentation, I think I showed something about. Oh God, where is this thing? Okay, I guess this was supposed to be yellow, and somehow I lost it. So I consider these three things, we have made good progress on that, and this is where I want to focus, and that is exactly, that encompasses what you're suggesting. That now, once we have modules and interface, a way to programmatically now look at these things, what else can we do? And that's one of those scenarios that I would like to investigate and see how we can make that possible. And clearly, it will also involve work being done in one of the study groups on reflection, right? So I actually put this yellow. I don't know why it didn't turn yellow, but this is where I want to focus now, because I think we've done componentization, we have done macroization. We're still talking about it, but I think this should be settled. And we know that we can get this. We have proof now we can get this, but this we haven't been talking a lot about it, and this is where I want to go. That's why I'm bringing the IPR in to generate codes, and you can, if you have the right tooling, you can read the IFC and regenerate things based on the IFC, right? You can regenerate declarations based on IFC. It is a data structure that you can manipulate with its coherence. Okay, Walter and sorry. Okay.
It seems like the import data format is actually the symbolic debugging format. So there should be a one-to-one correspondence between them.
There are a lot of debuggers around. Okay, and if you take one implementation strategy, you could equate them, but I don't think that would be a good choice. The IPA is really the highest levels with all the informations, like when this identifier was resolved, what were the other candidates that were there, right? It's a lot of stuff that some debuggers don't care about. Yeah. So on purpose, we're trying to keep the highest levels of C++ semantics. Yes.
Is there going to be a notion of, this kind of gets back to the introspection, .NET has a notion of, I guess, friend modules, which is like, you have the classic case is unit testing. You have all of your actual source in one module, and then you define a friend module, which has all of your unit tests, and your unit test can still see inside of the other module. They can still see the internal functions.
Mm-hmm.
Is there a notion of friend modules here, or are modules completely isolated black boxes?
So, very good question. So I've got that question several times from my friends who spent time on .NET since work for Microsoft. At this point, there is no notion of friend modules or friends assembly. It's not that I'm ruling out. It's just that it is not there yet, because I would like to see some other scenarios, and because my friend, they don't seem to agree that was a good idea. Everybody has their own opinion. Oh yeah, that's a great thing. Oh no, really, don't do that, right? I would like to see more use cases. And the other thing is that with modules, what you're having as protection is visibility, right? And if you have the right tooling, you can still call into something if you have the right tooling. Right. But the rules are about name lookup and what is visible. Right. And it is not protection in terms of the way .NET does it. It has kind of metrics. .NET has a matrix, public, private, and yeah.
You won't be exporting private. You said earlier, you won't be exporting private function language or private.
Yeah. So that's just what I would like. The committee is still not agreeing with me with that. The committee still believes that if you don't export private member functions, then you're not doing right C++. We're still debating that. I believe that if it is private, it's private, and there is no point in exporting it. So this is one of those cases where it is good to have an implementation and try it and see whether the theories actually yield to something useful, right? I think you had was it you? Oh.
Yep, that's me.
Oh, okay.
Okay, so are you going to be around a little bit more for questions if somebody has them? Anyway, thanks everybody for coming, and yeah, good talk. Thank you.
Yeah, thank you.